The Titanic didn't sink just because it hit an iceberg. It sank because of a fatal flaw in the steel itself. For over a century, we've obsessed over the captain, the iceberg, and the sheer bad luck of that night. But today, we're ignoring the drama and focusing on the raw engineering. We're going to dissect exactly how the biggest machine of 1912 failed under pressure, and how the same structural secrets hidden in the wreckage reveal why the ship couldn't stay afloat. But while the ship is dying, it's finally giving up its secrets. By looking at the newest wreckage data, we can see exactly where the structural integrity failed first. In this video, we're going to trace the physics of that collapse to understand how the pride of the White Star Line actually came apart. We have thousands of hours of footage of the Titanic on the ocean floor. But most people look at the ghosts. I want to look at the machines. Today, we're conducting a forensic analysis of the Titanic wreckage to rebuild the chain of events that turned an engineering masterpiece into the 20th century's greatest maritime disaster. It was designed to be unsinkable. But the wreckage proves this single engineering decision doomed thousands of people. We have thousands of hours of footage of the Titanic on the ocean floor. But most people look at the ghosts. I want to look at the machines. Today, we're conducting a forensic analysis of the Titanic wreckage to rebuild the chain of events that turned an engineering masterpiece into the 20th century's greatest maritime disaster. To understand why it collapsed, we have to understand how it was built. The Titanic wasn't just a ship. It was the largest moving object ever built by human hands. The design relied on 16 watertight compartments. If 4 of them flooded, the ship would stay afloat. It was the ultimate safety redundancy. But that redundancy relied entirely on the integrity of the steel and the fasteners holding it together. Here's where the engineering forensic really starts. For years, we thought it was just the sheer force of the iceberg, but modern analysis tells a different story. The steel used in the Titanic was high in sulfur, making it brittle in freezing temperatures. When the ship hit that iceberg, the hull didn't just bend, it fractured. And the fasteners, those rivets were iron, not the superior steel rivets used on other ships. Under the extreme pressure of the impact, they didn't just break, they sheared off, allowing the hull plates to separate like a zipper. If you look at the wreckage today, you can see the proof. You don't see large holes. You see long, jagged tears where the plates pulled apart. This isn't the result of a single catastrophic crack. This is the result of thousands of rivets failing in sequence, one after another, as the structure lost its integrity. The unsinkable design collapsed not because of a design flaw in the compartments, but because of a failure at the molecular and fastener level. The Titanic wasn't just a story of tragedy. It was the ultimate lesson in the limitations of 20th century materials science. The wreckage remains there to teach us that even the most massive machines are only as strong as their smallest components. If you're fascinated by the engineering behind history's most extreme disasters, make sure to subscribe and hit the notification bell. We've got more forensic deep dives coming. What machine should we analyze next? Let me know in the comments below.